All right, let's get into it. Today, we're going to look at modern cybersecurity, but not as just one big problem. Instead, we'll see it as a two-part challenge. It's a story about, first, how you draw a map of a world that's constantly changing, and second, how you train a guardian that's smart enough to actually protect it. So let's just start with a question to frame this whole thing. How in the world do you guard a city that completely rebuilds itself every single minute? Because honestly, that's what our digital networks are like today. They're sprawling, they're chaotic, and they're always in motion. For years, cybersecurity was kind of like guarding a fortress that had a fixed blueprint, right? You knew where all the walls were, you knew who had the keys, and you knew exactly what belonged inside. But that's just not the world we live in anymore. Our networks are more like living ecosystems, and those old blueprints, they're totally useless. The old way of doing things was to keep a manual list, an inventory of every single device on your network. But just think about that for a second. With the explosion of Internet of Things devices and companies letting employees connect to their own phones, their own laptops, that manual list is out of date before your finger even leaves the enter key. It's basically a snapshot of a world that's already gone. So, where do you even begin? Well, the first step is actually pretty simple, but it is absolutely fundamental. You have to create a map, because it really boils down to this. You can't protect what you can't see. If you don't know what's on your network as it exists right now, you have zero hope of actually defending it. And when you put these two approaches side by side, it's really night and day. The old way with manual lists was static, it was always incomplete, and it just couldn't keep up. The new way, based on some really cool research, is a living, breathing, automated map. It doesn't just list devices. It actually understands how they're all connected and what they're up to, creating what the researchers call a real, alive model of the whole system. So how does this magic map even work? Well, the key is a technique called event correlation. The best way to think about it is to imagine it's a detective. Every single thing that happens on your network leaves behind little clues in these things called system logs. Event correlation is the tech that automatically sifts through millions of those clues and starts noticing patterns, like, hey, these two clues always show up together. And by doing that, the system can define what a device is and what it's for, all without a human ever having to write it down. And the process itself is actually pretty elegant. First, the system just listens. It quietly collects all those event logs from everything. Then it crunches the data, looking for properties that are always paired up, like a specific process ID that always runs with a specific process name. And finally, it groups those linked properties together to build that live, always current map of every single asset on the network. Okay, so having a map is absolutely critical, right? But that's just half the battle. To really get why the next part matters so much, we've got to raise the stakes. Let's move away from just thinking about corporate data and talk about something way more personal. A situation where a security breach isn't about losing money, it's about life and death. Researchers in the Journal of Informatics and Web Engineering put it about as bluntly as you can. Security breaches in pacemakers can be a direct threat to a patient's life. See those wireless features that let doctors monitor the devices from afar? They also, unfortunately, create a perfect doorway for attackers. And the kind of attacks we're looking at are, well, they're terrifying. A hacker could remotely change a pacemaker's settings, they could drain its battery so it dies way too soon, or they could even trigger a fatal electric shock. This is not science fiction, folks. This is a documented risk with massive real-world consequences. And this isn't just some hypothetical threat. Get this. In 2017, the U.S. Food and Drug Administration had to recall nearly 500,000 pacemakers, 465,000 of them, all because of cybersecurity flaws that left them wide open to these kinds of attacks. That number just shows you the staggering scale of this problem. So, we have our map, we can see everything. Now what? Now we need the guardian. We need an intelligent, active defense system that's watching over that map. One that's capable of spotting a threat to something as critical as a pacemaker and doing it in real time. And this, right here, is where artificial intelligence enters the picture. So what the researchers did was actually pretty brilliant. They set up a contest, a bake-off between two popular types of AI, what we call machine learning models. They trained them on a whole mix of data, not just the network traffic, but also the patient's own biometric data, things like heart rate and blood pressure. The big question was, which AI could get better at telling the difference between what's normal and what's a cyber attack in progress? Okay, let's break down the results. The two AIs they tested were a support vector machine, or SVM, and a gradient boosting machine, GBM. And as you can see, the GBM model pretty much cleaned up. It was more accurate, it was more precise. But hold on, there is one number on this chart that is way, way more important than all the others. Look at this chart right here. This is a metric called recall. All that means is, what percentage of actual attacks did the AI manage to catch? And the difference is just staggering. The SVM model, it only caught about 43% of the real threats. The GBM model, on the other hand, caught almost 95%. It was more than twice as good at its most important job. So here's the bottom line, the thing that really matters. One of our digital guardians missed more than half of the intruders. The other one spotted almost all of them. And when you're talking about a tiny device that is literally keeping a person alive, well, that difference isn't just a number on a chart. That difference is everything. So now let's bring it all home. The future of doing cybersecurity right isn't about picking one single solution. It's about combining these two really powerful ideas, the complete, living map and the smart, ever-watchful guardian. Think about it like this. The map, that's your foundation. That's the real-time inventory that gives you total visibility into what's happening. It tells you exactly what you need to protect. And the guardian, that's the fortress you build on top of that foundation. It's a smart AI trained to watch everything on that map, and crucially, trained to be incredibly good at actually catching the bad guys. And all of this really leads us to one big final question for the future. As every single part of our lives becomes more connected, from our cars to, yes, our own bodies, our vulnerability just keeps growing. In that hyper-connected world, who are our greatest protectors going to be? Will it be human experts? Or will it be the tireless, vigilant AI guardians that we ourselves create to watch over us?